So for this problem, to expand this algebraic expression using the Pascal's triangle, so take note that in the Pascal's triangle, so this is 1, starts with 1, ends with 1, then we have 1, then 1 plus 1, that's 2, then ends with 1, then this is 1, 1 plus 2, that's 3, 2 plus 1, that's 3, then ends with 1, then 1, 1 plus 3, this one is 4, 3 plus 3 is 6, 3 plus 1 is 4, then 1, then again starts with 1, 1 plus 4, this one is 5, 4 plus 6, that's 10, 6 plus 4, that's 10, and 4 plus 1, that's 5, then ends with 1. So just continue the process. And for the binomial, so this is x plus y to the power 0. This is x plus y to the power 1, x plus y to the power 2, x plus y to the power 3, and this is x plus y to the power 4. So we have x plus y to the power 5, and this one is x plus y to the power n. So from this given, to expand this expression using this Pascal's triangle, so since the exponent is 5, so we have this the exponent 5, and these are the numerical coefficient. So we have 1, 5, 10, 10, 5, and 1. Then for the first term, so we have 3x, so starts with 3x to the power 5. Then in descending order for the exponent, so we have 3x to the power 4, 3x to the power 3, 3x to the power 2, and 3x to the power 1. Then for the second term, that's negative 2y. So we're going to start at the last term. So this is negative 2y to the power 5. Then backward, negative 2y to the power 4, negative 2y to the power 3, negative 2y to the power 2, then negative 2y to the power 1. Then for the operation, so this one is all plus. So plus, 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 and plus. Then to simplify, so this 3x to the power 5, so since 3 to the power 5, so for 3 to the power 5, so that's 243. So this is 243, then x to the power 5, then plus, so we have 5 times this 3x to the power 4. So 3 to the power 4, that's 81, then x to the power 4. Then bring down this negative 2y, then plus, so bring down 10, and this 3x to the power 3. So 3 to the power 3, this one is 27, x to the power 3. Then for this negative 2 to the power 2, so negative 2 times negative 2, this one is positive 4. Then y to the power 2. Then plus, so bring down that positive 10. Then this 3x to the power 2, or 3 to the power 2, this one is 9x squared. Then for this, negative 2y to the power 3. Now take note, for negative numbers, we need to put inside the parentheses. So negative 2, then to the power 3. So that's negative 8. So this is negative 8y to the power 3. Then plus, so bring down positive 5. Then bring down 3x. And for this, negative 2y to the power 4. So again, we need to put inside the parentheses for negative numbers, then to the power 4. So that's positive 16. So this is 16 y to the power 4, then plus this negative 2y to the power 5. So we have inside the parentheses, so negative 2 to the power 5. So that's negative 32 y to the power 5. Then to simplify, so just bring down this 243 x to the power 5. Then we need to multiply these three numbers. So 5 times 81 times negative 2. So we have 5 times 81 times negative 2. So that's negative 810. So this is negative 810. Then just copy the variables x to the power 4 times y. Then for this, multiply these three numbers. So this is 10 times 27 times 4. So that's 1080. So plus 1080, then bring down these variables, x to the power 3 and y to the power 2. Then for this, multiply these three numbers. So that's 10 times positive 9, then times negative 8. So that's negative 720. So minus 720, then bring down these variables, x to the power 2 and y to the power 3. Then for this, 5 times 3 times 16. So we have 5 times 3 times 16. So that's positive 240. So plus 240. Then bring down the variables x and y to the power 4. Then for the last term, since positive and negative, so this becomes negative or minus 32 y to the power 5. So this is now the expansion for this binomial.